Find the volume of the right prism or right cylinder. Now remember, in this case, you want to find out how many blocks that are centimeter by centimeter will fit in the bottom. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 7. 1, 2, 3, 4, 5, 6, 7-ish. Okay, so for this one, you're going to do the volume is equal to length times width times height. And remember, I've taught you that length is the long way. 12 times 7 times 4. 12 times 7 will be how many of these blocks will fit down here in the bottom. And then you have 4 layers of them. So 12 times 7 times 4 is 336. So for number 10, it's 336. And this is centimeters. 12 centimeters times 7 centimeters times 4 centimeters. So this will be centimeters cubed. Okay, now I know you love to do these, but you learned how to do them and you can do them well, so I'm sure you'll be fine. This is a regular pentagon. So when you look at the pentagon from the distance, now let's just go back and look at our theorem list. Okay, to find the volume of a prism, it's base times height, big base. So it's the area of the base. And it really doesn't matter what shape it is, but you have to identify the shape of it so you know which area to use. And since we're doing the area of a pentagon, it's going to be the area is equal to 1/2 the apothem times the number of sides times the side length. Or you can just put in perimeter for this if you'd like. All right, so we have a side length, but we don't know what the apothem is. So we're going to look at our pentagon that we drew up here. It doesn't have to be beautiful. All right, now since there are 5 of these triangles, count them. 1, 2, 3, 4, 5. Feel like you're on Sesame Street? Okay. And since it goes all the way around in the whole figure, that's 360. So we're going to divide 360 into 5, so we can, because we have 5 angles right there. So the whole angle is 72. Well, we're going to be looking at finding the apothem, and so we're going to be looking at this 36-degree angle, and we're going to see that the side length is 8, and that's for the whole side length, so that makes this part of it 4. We need the height, so when we look at our right triangle, here's our 36-degree angle. We have the opposite side. It's opposite from that angle. We need the adjacent side. So when we think of SOHCAHTOA, that's our trig thing we need to be able to do. SOHCAHTOA. All right, we say I need the opposite side. Well, I have the opposite side and I need the adjacent side. So we're looking at tangent. So tangent 36 is equal to the opposite side, which is 4, over x. So we're going to multiply both sides times x, and then we're going to divide by tangent 36. So you punch this into your calculator. Boy, you really just can't read that. Let me see if I can fix that. We're dividing both sides by tangent 36 degrees. So in your calculator, you're going to write 4 divided by, now if you have a Texas Instruments, you'll put in tangent and it'll give you a parenthesis, and then you'll just put the 36 there. You don't have to end the parentheses if you don't want to. If you're using one that gives you the tangent after you put the number in, you'll put in 4 divided by 36 tangent. Now when you press tangent, you'll get whatever 36 tangent is. You'll have to press equals to get it to do this division here. Okay, so 4 divided by tangent 36 is 5.50, except it's got a 5 after it, so it's going to be 5.51. All right, so now we know that the apothem is 5, I think I'll draw it down here. Okay, it's 5.51. All right, so going back to our area right here. Okay, the area is equal to 1/2 of 5.51 times the number of sides, which is 8, excuse me, times the number of sides, which is not 8, it's 5. And I'm going to put that in the right order just so you can really follow it well. And then the length of the side. Or you could just do the perimeter. Because these two together are the perimeter of 40. Okay? So 1/2 times 5.51 times 5 times 8 is 110.2. And that's the area of a pentagon. So we're going to draw that area of the pentagon, or if you don't want to draw it, you can just write pentagon. And it's 110.2. Now, if you've forgotten, we'll go back and look at our formula. It's the area of the base times the height. So that makes it very easy for us. Go back over here. We said we've got the area of the base. So the volume is equal to 110.2 times, what's the height? 15.5. 110.2 times 15.5 is 1,708.1, and that's in meters, and because it is little cubes, it's cubic meters. Okay. Now remember that because we're dealing with trig, you know, you might be off by 1/10 of a point or by a whole point. It just depends on where you clear that calculator and where you do your rounding. Because you do not have explicit instructions on that, I'm not going to worry about that. When you get into chemistry and you have significant figures, you'll have more time to talk about that. All right. Looking at our cylinder over here, again, it's going to be volume equals the area of the base times the height. But you got to look at this thing and say, what is 21.9 referring to? Because the whole line is drawn in there, and I will show you again that it is. You know that 21.9 is also referring to the center of it. So 21.9 is referring to that whole diameter. If you make a mistake where you use the wrong thing, don't stress over it and do it twice and say, I didn't know what it was talking about. Don't worry about it. Just clearly label your parts and I will give you credit either way. Alright, so we want to find the radius because we need the area of the circle to do pi r squared. Excuse me, we need the radius of the circle. So when we divide 21.9, we get 10.95. I'm going to square that and multiply times pi. So, whoops. Squared is 119.9025 times pi. And that gives us 376.68. And then we're going to multiply times the height because volume equals the area of the big base times the height. Times the height is 10.3, 3,879.85. Okay, and that's the volume of that cylinder. Alright, now we're going to do some volumes of weird stuff. It's so easy because all you have to do is follow the formula and you have that in front of you. So the volume of a pyramid is 1/3 the area of the base times